The Laplace transform is a method that allows us to replace difficult differential equations by easily solvable algebraic equations. And we want to solve difficult differential equations to understand the time response of a physical system. A physical system can be a number of systems that we know. For example, a cart that we are pushing could be an electrical circuit, could be a liquid level system. There is a number of examples of physical systems. So our goal is to find the time response solution of a physical system. For that, we're going to follow the following steps. First, obtain the linearized differential equation. Two, we're going to obtain the Laplace transform of the differential equation. And three, we're going to solve the algebraic equation, the resulting algebraic equation. It's important to understand that the step number 2 results in an algebraic equation. Which is the one that we solve in step 3. There are two concepts that are important to understand the Laplace transform. The first is the concept of complex variable, and the second, a complex function. So, complex variable. Complex variable is given that the real part of the imaginary part of a complex number is a variable, then we have a complex variable. So let's see an example. For example, we can look at the complex variable s, which is equal to sigma plus jw, where in this case we have sigma, that is the real part of the complex variable, and omega is the imaginary part. Notice that sometimes I will use the letter omega, and sometimes I'm going to refer this as w. Regarding a complex function, we can also define it very easily. Complex function is a function of the variable s that has a real part and an imaginary part. So in this example, in a similar way, we can define this complex function g of s, which is going to be gx plus j gy. The real part is gx, and the complex part is gy. Therefore, the magnitude of gs is the square root of the real part square plus the imaginary part square. And the angle of gs is defined as the arctangents of the imaginary part over the real part. Finally, so the Laplace transform is going to be defined as L of f of t, where f of t is a function in the time domain. Sometimes we're going to call the Laplace transform as capital F of s, which is the integral from 0 to infinity of a function f of t e power minus st multiplied differential of t. It's important to understand that the variable that changes on the limits of 0 to infinity is t.